In question 7, the sum of the first two terms of a geometric progression is 15 and the sum to infinity is 125 upon 7. The common ratio of the progression is negative. We have to find the third term of the progression. Now, if it is a geometric progression, the nth term is given by a r to the power n minus 1. Now, the first term is a, the second term, so the second term will be a r to 2 minus 1, which is equals to ar. So the sum of these two terms, the first term and the second term, that is equals to 15. The sum to infinity is given by the formula a upon 1 minus r, and that is equals to 125 upon 7. So we can write 125 upon 7 will be equals to a upon 1 minus r. Now, solving these two equations simultaneously to find the value of a and r, we know that if we can take a common over here, this can be written as 1 plus r is equals to 15. So a will be is equals to 15 upon 1 plus r. Now substituting this equation into the second equation, so this is the second equation. In place of a, we can write 15 upon 1 plus r. So this will become 125 upon 7 is equals to, in place of a, we'll get 15 upon 1 plus r. And there was already a 1 minus r in the denominator. So cross multiplying, this will become 125 and 1 plus r into 1 minus r can be written as, using the algebraic identity, this will become 1 minus r squared. So this will become 125 into 1 minus r squared is equals to 7 into 15, which is 105. So 1 minus r squared will be 105 upon 125, which we can now simplify it and write it as, so taking the r squared on the right hand side, so this will become r squared will be is equals to 1 minus 105 upon 125. Taking the LCM, this will become 125 minus 105. So this will become 20 upon 125. Dividing by 5, this will become 4 upon 25. Now, as r squared is equals to 4 upon 25, taking the square root on both the sides, we'll get r will be is equals to plus minus 2 upon 5. And as the question said, that the common ratio of the progression is negative. So we'll take the final value of r as minus 2 upon 5. Now, as we have to find the third term of the progression, we need the value of a as well. And we know that a plus ar is equals to 15. So we can use this, or we can use the second equation as well to find the value of a. So using the first equation, which is a is equals to 15 upon 1 plus r. So we know that a is equals to 15 upon 1 plus r. So this will become 1 plus minus 2 upon 5. Taking the LCM, this will become 15 upon, this will be 5 minus 2 upon 5. Simplifying this will become 75 upon 3, which will be equals to 25. Now, once we have the value of a as 25 and the value of r is minus 2 upon 5, the third term will be is given by the formula ar to the power n minus 1. A is 25, r is minus 2 upon 5, and this will be n minus 1. So this will become 3 minus 1. We can write it as 25 into minus 2 upon 5 whole squared, which is equals to 25 into 4 upon 25. 25 and 25 will cancel. So the third term of the progression will be is equals to positive 4.